All right, so the metric system is used in most countries, okay? The United States uses imperial still. They use inches and feet and miles and gallons and all that stuff, but we use the metric system along with almost every other country, okay? And because it's base 10, it's easier to remember because everything's related in tens, okay? Whereas the imperial system, like, there's sixths and twelfths and eighths, and so a lot more just general knowledge you have to have in your brain in order to use it. This one's always by a factor of 10, which makes it easy. So our base unit for measurement of like length, everything is meters, okay? And then this way we're getting smaller units. So a decimeter is 1/10 of a meter. A centimeter is 1/100th of a meter. A millimeter is 1/1000th of a meter. Okay? And then going this way, these units are bigger units. So we know a kilometer is bigger than a meter. 1 kilometer is 1,000 meters. Okay? So if this is easy to understand. If we have this is 1,000 meters, 100 meters, 10 meters. So 0.1 meters, 0.01 meters, and 0.001 meters. Okay, so that's everything in terms of meters there. A decameter is 10 meters, a hectometer is 100 meters, a kilometer is 1,000 meters. Okay? And a decimeter is 0.1 of a meter, or 1/10 of a meter. Centimeter is 0.01 of a meter, and a millimeter is 0.001 of a meter. All right, so just some reference examples. So if you're thinking a millimeter, it's the width of a tuning, about, okay, the width of a tuning. A centimeter is about the height of an eraser, okay? A meter is about the height of a small child that's playing t-ball. Kilometers. So I can't read that. It looks like to go from, is this somewhere we recognize? I don't think so. But okay, so on a map then, 0.4 kilometers and 0.6 more kilometers gives you 1 kilometer, so. All right, so metric measurement, to change from centimeters to millimeters. So say you have 2 centimeters and you want to change it to millimeters. What would you have to do? You can see it on your ruler if you have a ruler out. What's 2 centimeters equal on your ruler? How many millimeters?
10 millimeters.
10 millimeters is a centimeter, so 2 centimeters would be 200 millimeters. Yep. No, 20. My bad, sorry. 20 millimeters. So we know one from our ruler. From a ruler, we can see that 1 centimeter is 10 millimeters. So 2 centimeters would be 20. And then how did you get from 1 to 10? Multiply by 10. Or Another way of thinking about it is to move the decimal one place to the right. Okay? So because millimeters is a smaller unit, there's going to be more of them than there was centimeters. So if you're looking at 25.54 centimeters and you want it to be millimeters, oops, you would move the decimal place one place to the right. So it would be 255.4 millimeters. So always make sure when you're doing metric conversions that the smaller unit, there's more of them. Okay, the smaller unit, there's always more of it. So you haven't divided instead of multiplied by accident. So to change from centimeters to meters, you would divide by, so if we look up, centimeters and meters are 2 gaps away. So what do you think you'd divide by? 2 what? Nope. To get from here to here, you divide by 10, right? To get from here to here, you divide by 10 again. So you divide by 100, okay? 10 times, so if you divide by 10 once and divide by 10 again, you've actually divided by 10 times 10, which is 100, okay? You divide by 10 twice. So you divide by 100. Or move the decimal. Oops. Move the decimal 2 places to the left. So because we're going from a smaller unit to a bigger unit, the number in front of the bigger unit should be smaller. We move the decimal 2 places to the left. So 25.5 centimeters is just 0.255 meters. Or you could have done 25.5 divided by 100. All right, to change from kilometers to centimeters. So kilometers to centimeters, let's look at our chart here. We're going 1, 2, 3, 4, 5. And are there going to be more centimeters? Yes, okay, because we're going from a big unit to a small unit. So each of these 5, you're multiplying by 10, multiply by 10, multiply by 10, multiply by 10, multiply by 10. Okay? How many times are we multiplying by? 1, 2, 3, 4, 5. So times 10 to the 5th. Multiply by 10 to the 5th. Oh, sorry. Yeah.
So bright in here.
Yes, it is.
And okay, awesome.
Can you wait up for
Yeah, thanks so much.
Okay. All right, so to change from kilometers to centimeters, we want to multiply by 10 to the 5th. Or what is 10 to the 5th, guys? If you put 10 to the 5th on your calculator, what do you get? Yep. 100,000. So 3.2 kilometers would become 3.2 times 100,000. Oops. Or 3.2 times 10 to the 5th. Okay? Or move the decimal place. See this nice number here when we learn scientific notation? Move the decimal 5 places to the right. Okay, that 5 there means move the decimal 5 places to the right. 1, 2, 3, 4, 5. Zeros go in here. So it would be 320,000 centimeters. Okay? Big number. All right, so here's a chart you may have seen in elementary school. So here's your base unit, which is usually the meter. If you're getting smaller, right? So a decimeter is smaller than a meter, a centimeter is smaller. You multiply by 10 for each step. Going down. And then if you're going from a smaller unit to a bigger unit, you divide by 10. Okay? So to go from a bigger unit to a smaller unit, you multiply by 10. To go from a smaller to a bigger, you divide by 10 each time.
Sorry,
Hi.
where's Dallas? Which year? Can I speak to someone quick?
You may.
Can I just go there and talk?
All right, now put your knowledge into action. Find the perimeter of the object. All right, so the first thing you notice when we're doing perimeter, well, is that you want to add up all the outside edges. So this is kind of a tie-in to yesterday. You've got your formula sheets out there. But first of all, a big mistake some students make is they include inside lines when they're finding perimeter. But for perimeter, you just want the outsides. Everybody good? And we do want it all in one type of unit. We don't want centimeters and millimeters and multiplying those numbers together. So I always like to work with smaller numbers. Is that a good plan? Work with smaller numbers. So I would want to change 400 millimeters to centimeters. Anyone, what do you think 400 millimeters would be as centimeters? Yep. 40, so you move the decimal 1 place, or you divide by 10 one time. Josh, why do I only divide by 10 one time? If you look in that chart there, how many spaces are millimeters and centimeters apart? 1, okay? So that's why I just divide by 10 one time, okay? Or move the decimal place to the left one time, because they're only 1 apart, okay? All right, so now I've got everything into centimeters. Everything's in centimeters now. Any ideas how I would go about finding the perimeter? There's a couple things, there's a lot in this question actually. Yep, Jacob?
To put a triangle, do c squared plus
Love it.
c squared equals a plus c squared.
Okay, so that's going to give me this side, but it's also going to give me this side. Do you guys agree with that? Okay, so if I use the Pythagorean theorem, this is going to be C. This is going to be A. What do I know about B?
Nothing.
I do. Because this diameter is 34 centimeters. So what's this length going to be, Braden, from here to here?
Divide by 2.
Divide by 2 because it's radius, right? So that's going to give me 17 centimeters. Okay, so I'm going to pause it. You guys figure out the length of... Okay, so c squared equals a squared plus b squared. C is always the hypotenuse, so that's the one we're trying to find. We don't know its length. A and B don't matter which is which, but they're the legs. So I've got 40 squared plus 34 squared. Now, if I forgot and I put 400 squared here, would the answer for C be correct? No, okay? So you have to be working with the same units in order to get the correct side length, okay? All right, so then we do the squares. So 40 squared is 1,600. And 34 squared, I don't know in my head. That's divided by 2. Oh, sorry, thanks, guys. Um, 17 squared, thanks. 289, good. Okay, so once you've done the squares, who remembers the next step? Add them, good. 289 plus 1600 is 1889. Okay, yeah. And then the last step. Square root. Both sides, so I'm gonna get those side lengths now. 43.5? 43.5, and remember they should be longer than each of the legs, which they are. So we know that side's 43.5 centimeters, and this side is 43.5 centimeters. And I know when I'm doing perimeter, I add the sides, right? So far I know these two are going to get added together. But I've still got one more number to put in, and that's going to be the length of this semicircle. Everyone agree with that? Okay, so how am I going to calculate the length of the semicircle? You've got a formula sheet, get your formula sheet out. So not area, but length. So if you look at your formula sheet, there's a perimeter on the very front, there's perimeter on one side and area on the other. So we're interested in perimeter because we just want to know this distance here. So if you look under the perimeter column, what formula does it give you for the perimeter of a circle, or circumference of a circle? What formula? Anyone? Get your formula sheets out. Yep. That's area. Perimeter, yeah.
2 pi.
Yeah, C equals 2 pi r. But since it's just a semicircle, what should I do with this formula so I only get half of it? Divide it by 2. So that's going to be 2 times pi. We figured out our radius was 17 divided by 2. And that's going to be, once we figure that out, that's going to be the third number we're going to put there. So 2 times pi times 17 divided by 2, 53.4. So there's our third one. And now we've got to add them up. And that's going to be our perimeter, all in centimeters. So 140.4 centimeters is the perimeter. So again, you can see that EQAO chooses questions where you have to know the Pythagorean. So in this one question, a multiple choice, there'd probably be 4 answers. You have to use the Pythagorean theorem. You have to know perimeter is the outside edges. You've got to be able to find the perimeter of a semicircle. So there's so much going on there for just one question, and there'll be 4 multiple choice answers. Okay, so when you're doing it, you'll have your whiteboards. You can have paper. Okay, but whiteboards are best because you can just erase and go on to the next question. Okay, but you have to do all this work, and then all you're going to do is choose A, B, C, or D. Okay. Perimeter is something they assume you learned in grade 7 and 8 because this grade 9 test is really on grade 7, 8, and 9. Like just like your grade 6 test was on 4, 5, and 6. How many people have a recollection of perimeter? Enough to know that you add the sides up around? Okay, good. And then if you have that formula sheet, that saves you, right? That helps you if you forget how to find the perimeter of a semicircle. You can always look on your formula sheet. All right, so this one's, I think, a bit easier. Jen walks 3,300 meters from her house to the school. After school, she walks 5 kilometers from the school to the library. How far is the library from Jen's house? And they've got an X here. Okay, I see lots of people with 3,300. They figured out That's here, and this is here. But you can't use the Pythagorean theorem yet because they're not the same unit. And I like to work with smaller numbers, so I want to change this to kilometers. Okay? So if I look at my list here, I want to go from meters, 1 step, 2 step, 3 steps, up to kilometers. So either I think of moving my decimal 3 places to the left, or dividing by 10 3 times. Okay, those are my options. Moving the decimal seems like the easier option, 3 places to the left. So if I do that, 1, 2, 3, I end up with 3.3 kilometers. And I like how Charlie said that 3.3 kilometers is 3 kilometers and 300 meters. That shows a really good understanding of what that number means. It's good. Okay, so now we're ready to use Pythagorean theorem. So this is C. A and B don't matter, but I'll label them like that. Let's do your squares. $10.89. Oh, I got 5.99 or approximately 6. You got your dot there, 6.0 kilometers. So how far is the library from Jen's house? So here's the library, here's your house, we calculated that. The library is 6 kilometers from Jen's house. So again, they're combining things. This time they're combining unit conversions and Pythagorean theorem in order to be able to get the solution. Here's another EQAO question. The sand falls at a rate of 50 cubic millimeters per second. How long will it take the sand to completely empty into the bottom part of the hourglass? Okay, so how many people picked kilometers for their unit? Okay, so we'll go by kilometers. This is 7 kilometers. What's 5,000 meters? 5 kilometers. Okay, and then if you forget that, remember we're going from meters to kilometers. So we're dividing by 10 3 times, or we're moving the decimal place 3 places to the left. Okay? So that little chart there is really handy. So see if I moved it 1, 2, 3 to the left, I'd have 5 kilometers. 27,000 centimeters. How many steps are centimeters and kilometers on our chart? So they are 1, 2, 3, 4, 5 apart. So 5 apart? Yeah. So 1, 2, 3, 4, 5. So this is 0.27 kilometers. And then 350,000 millimeters. They're 6 apart. 0.35 kilometers. So how am I going to figure out how far they are from their starting point? So here's where they start. How do I figure out how far away they are from their starting point? So do you want to figure out how far right they went and how far left they went first? Okay, so how do you figure out the total amount they went right? At 7 kilometers plus 0.27 kilometers. It's 7.27 kilometers. Is everybody good with that's how far right they went? And now let's figure out how far left they went. 5 kilometers plus 0.35 kilometers is 5.35 kilometers. So they're going to end up, so looking at comparing these, are they going to end up right of their starting point or left of their starting point? Right, because this number is bigger. Okay, so we know they're going to end up right. And then how do I figure out how far right from their starting point they would end up? No, this is how far we went right, but we also went this far left. So how do I figure out how far right I ended up from the beginning? Subtract them. Awesome. So 7.27 subtract 5.35. 1.92. So they're going to be 1.92 kilometers right of the starting point. That was another EQAO question. Okay, so you make you convert everything, and then they'll have 4 answers. One will have left. One will have you adding these two together instead of subtracting. Like they'll make all the common errors. Okay. One more. And there we go. Forget. And this one's actually pretty straightforward. All right, what is the volume in cubic meters? So this is a, you can think of it as a rectangular prism. It kind of does, but they're different lengths, so it's not. So the volume, if you look at volume of a rectangular prism, that's the one that you kind of all started your, before you realized it was area, length, width, height. But we want them in meters, not in centimeters. So how do I change each one to meters? How far apart are centimeters and meters on the chart? How many steps? Nope, 3. So I'm going to move the decimal place 2 places to the left, so 0.95 meters, 1.2 meters, and 1.05 meters. So once you've done that, you just have to put them in the formula. So my length is 1.2. My width is 1.05, and my height is 0.95. Multiply them together, and you'll have the volume in cubic meters. Approximately 1.2, because it's 1.197, and then I'll round the 2 up. 1.2 cubic meters. Okay, so that was a combo, switching units and finding the volume of a rectangular prism. Because there's a 0.95 here, so that's getting left. Like that makes it smaller. If they were all bigger than 1. All right. Good. That was a good question. I guess